Thank you, everyone. So I'm going to be talking about the type of RO systems that would be appropriate for use on private wells. We call these point-of-use RO systems. They're generally small systems installed under the sink. They come with their own separate faucet. You're only going to be using this system to treat water for drinking and cooking. So you're going to use it to treat a very small quantity of water. That's typically less than 1% of the total indoor water usage for a typical home. So you're treating a small quantity of water. They're very inexpensive systems. The membranes last a really long time. Most of these systems do not use electricity. The system itself is not going to require any electricity. The only time you'd ever need to use electricity is if you install a booster pump, which we'll talk about why you would want to install a booster pump. All right, so before we get started with the RO stuff, though, I want to talk about something fun. So as I mentioned to several of you, I'm moving to Utah next week. And it's been a journey. I've been doing nothing but packing. Anybody here from Utah, by the way? All right, we got to connect later. Oh, okay. Well, you may recognize this picture. So people keep asking me, why on earth would you want to move to Utah? And I keep telling them there's all kinds of fun things to do in Utah. For example, here's a picture of me drinking spring water straight out of a tree. I mean, come on. Okay, no reaction from that at the private well conference? Now, admittedly, this is probably a questionable visual to start with at the private well conference where we're supposed to be focused on water quality, but this spring is different. If you Google this spring, it's a spring in North Ogden. This spring is actually so popular and the water tastes so delicious, the Primacy Agency has regulated it as a public water supply. You can actually go online and read their CCR. I'm telling you, it's delicious. So remember this when Steve starts surveying us about where we want to do the next private well conference. We all want to go to Utah because there's a lot of fun things to do in Utah. All right, so I'm going to start with some teasers on the RO systems. Some of these statements are true. Some of them are false. At least one of these statements is often used as a misleading sales tactic. And I'm not going to give you the answers up front, but if you're listening as I go through my talk, the answers will become obvious to you. So the first one, RO water is corrosive. RO water is too pure, it will harm your body. RO systems can remove a wide variety of contaminants, and using a booster pump to increase the water pressure across the membrane is going to make the system fill your glass faster, but it's going to result in lower quality water. So some of those are true, some of those are false. So before we get into the RO system technical stuff, I want to stress that the first thing we always teach water treatment professionals and consumers when they call us is you need to test your water first. You need to test your water because you need to know if there's any health-related contaminants in there. But also, you need to understand the water chemistry because if you're going to make a good recommendation on a treatment strategy, you need to understand the water chemistry, and I'll touch on why that is as we go through. This slide compares the different membrane technologies. Real quick, at the top you have microfiltration, which is just removing suspended solids, all the way down to RO, where you are removing those monovalent salts. And in each case, you can see the water's going right through. So the concept here is you have a semi-permeable membrane, water goes through, and specific contaminants are rejected. So it's not like a filter where a filter is capturing things. In an RO system, all it's doing is diverting things from your cup. So it's just diverting the contaminants from your cup, not capturing anything. What types of contaminants can RO remove? So as you probably guessed from the last slide, this is your first answer. RO contaminants can remove a wide variety of contaminants. A basic RO system is going to be designed to remove TDS, total dissolved solids, but you can also design them to remove metals, including arsenic, lead, uranium, certain organics, including PFAS. In fact, with PFAS, they're not susceptible to the chain link limitations that you might find with some of the medias. Short chain, long chain, they do equally as well. You can also design them to remove inorganics like nitrate and fluoride, and even macromolecules like bacteria. But just because you can design an RO system to remove all those things doesn't mean the one that you buy is going to be designed to remove all those things. So a basic RO system that is certified under NSF Standard 58, the only requirement, the basic requirement for certification is it has to remove 75% of the TDS. That's it. And you're probably not buying systems just because you're worried about TDS. So the key takeaway here is when you are, first you need to test the water, understand what health contaminants you're dealing with, and then look for systems that are certified to remove those specific contaminants. And those contaminants are all optional claims under 58, so you have to actually go to the certifications and look and see what it's certified for. Here are all the certification bodies. There's 6 different accredited certification bodies in the US and Canada, and I've included their websites here, so you can go see what products they've certified, what they've certified them for. This process becomes very complex to navigate, and I'm happy to help. My contact info will be at the end, or it's also in your binder. So most of these RO systems are designed with what's called thin film composite, and that's because it has excellent thermal stability, it's bacteria resistant, tolerates a wide range of pH. It's great stuff. That's why they use it. What it doesn't like is oxidizing agents like chlorine. So chlorine, if you let chlorine get to your membrane, it's going to destroy your membrane. So that's why when you purchase one of these, you'll see it comes with multiple replacement components or replaceable modules. Those 3 cartridges along the bottom. One of those is the RO. There's probably a pre-filter and a post-filter in most systems as well. That pre-filter is there to protect the membrane from things like chlorine and other stuff that would damage the membrane. So it's important that you keep up on the maintenance of all those modules. So getting into how RO works. This is really important for you guys to understand how these systems work, because I want to talk about how people go wrong with implementing them. These systems are, as I said, relatively inexpensive. They're super easy to install, so a lot of people just buy them online and install them themselves, and sometimes they don't read the instructions, and they make mistakes that compromise the performance of the system. So to understand that, I want to explain how these systems work. You have, as I mentioned, a semi-permeable membrane. Water passes through, contaminants don't. I'm showing the water here as these small blue dots. The contaminant is the large red dot. Imagine that to be arsenic, whatever contaminant you want to remove. If the water passage across the membrane is proportional to the pressure gradient across the membrane. So if you can imagine me pushing on the left side and creating more pressure, I'm going to push more water through that membrane. But the salt passage, the rejection, is based upon the concentration differential across the membrane. So I push on the left side, push more water through, I'm not pushing any more contaminants through. The key takeaway there is higher pressure differential across that membrane is going to give you higher quality water. So just to recap all that, water passage is proportional to the pressure gradient, but the salt passage is proportional to the salt gradient, or contaminant passage is proportional to the contaminant concentration above the membrane. So the quality of your the quality of your treated water then really depends upon the pressure that you're providing across the membrane and the quality of your feed water. And each salt is going to have its own rejection rate for these membranes, and the membrane is going to have a very high rejection rate, over 99%. But each salt's going to be different. So you can kind of think about it as this membrane is going to reject a certain percentage of lead, a certain percentage of TDS or whatever contaminant you're trying to remove. So let's talk about how this impacts nitrate. Let's say you're using an RO system for removal of nitrate. All of the certified claims for nitrate removal for RO systems are based on us testing that that system at either 50 psi or what the manufacturer calls their minimum recommended inlet pressure. So if we test it at 50 and it passes for nitrate, but you're working with a private well owner and they're only getting 30, you're not going to get the certified performance out of that system. So it's important that if you're dealing with nitrate, specifically nitrate, because the manufacturers have this option of changing the pressure, that you understand what test pressure was used for certifying that nitrate claim. And again, you can get that out of the manual. Look for the manufacturer's minimum recommended inlet pressure. If you want to improve the performance then for nitrate, what would you do? You would increase the pressure differential across the membrane. There's two basic ways you could do this. A booster pump would be one. Booster pump is going to require electricity. It's just going to increase the pressure coming into the RO. The second way is a permeate pump. A permeate pump runs off hydraulic pressure from the reject line, doesn't require any electricity. It's basically using the hydraulic pressure from the reject line to help push water into the pressurized storage tank. So it's overcoming the back pressure that's provided by the pressurized storage tank downstream of the membrane. Therefore, it's increasing the pressure gradient across the membrane, just like a booster pump would. Now, neither of those two things is going to make the system fill your glass faster. And this is something some consumers don't like. You may notice if you've owned one of these things, the first person to get water in the morning when the tank is nice and full, the water's going to come out pretty fast. It's going to fill your cup pretty quickly. As if you have a large family that's using a lot of water throughout the day, as that tank empties, it's going to start filling cups slower and slower because there's less water in the pressurized tank, and it's pushing water out into the cup based on the precharge of that tank. So when the tank is empty, it typically has like 5 psi precharge in there. That's what's pushing the water out into your cup. So if you're not getting if you feel like it's not filling your cup fast enough, one of the first things to check is, has your tank lost its precharge? The way you'll know this is you empty the tank, or what you think is empty. You run the system until there's no more water coming out, right? Then you look under the sink, shake the tank. If it's still got water in it, then your tank lost its precharge, because there shouldn't be any water left in that tank if there's no more water coming out. And there's instructions in the manual on how to redo the precharge. It's not very difficult. The other option you can use is what's called a repressurization pump. Again, this would require electricity, but you install this after the tank, and all it's doing is sucking water out of the tank faster to fill your cup. Has no impact on performance whatsoever, one way or the other. The other thing to look for if you're dealing with a system that you feel it's struggling to provide water, especially if you feel it's struggling to fill the tank, it should easily fill the tank overnight. In fact, ours at the WQA facility fills we have multiple people using it throughout the day, and it fills the tank multiple times throughout the day. No problem should it fill the tank overnight. But if your system is not filling the tank overnight, if you think it's struggling to fill the tank, it probably needs maintenance. Real quick on arsenic, yesterday there was a talk on a family that was using an RO system to remove trivalent arsenic. So that's not recommended with these systems. The certifications for arsenic on an RO system are all based upon removal of pentavalent arsenic. It's not recommended that you use a RO system like this to remove trivalent arsenic. The one thing you can do, though, if you're dealing with trivalent arsenic, is you can chlorinate the system. And that will obviously also help if you're dealing with a well that's struggling with bacteria issues. So when you chlorinate the system, you properly chlorinate it, you're going to convert all of the trivalent arsenic to pentavalent. Then the chlorinated water is going to go into your RO system. The pre-filter will remove the chlorine to prevent it from damaging the membrane. The membrane will reject the pentavalent arsenic. There's some other water chemistry factors that can impact performance. The one you're probably most likely to run into is hardness. Hardness will shorten the life of your membrane. That's the trade-off here. So there comes a point where it just makes more sense economically to put in a water softener, pre-treat the water before. the RO system, and then your RO system, your membrane will be protected, last a really long time. Some of these membranes are guaranteed to last for up to 10 years if you follow the manufacturer's instructions on recommended hardness levels. But then you have the RO system there too to remove the sodium that's added by the softener, so best of both worlds. Iron and manganese are other ones you probably might run into. And again, in certain water chemistry, you might be able to get away with using a softener to remove iron and manganese. In other cases, there's other treatments that you would have to use to remove the iron and manganese first. In terms of installation, a couple things to keep in mind. RO water is corrosive. So that's why they come with plastic tubing and a separate non-leaded air gap faucet. You don't want to have any metal tubing downstream of the RO system. Some consumers do not like the air gap faucets because they gurgle. They'll make a gurgling sound while the system is filling the tank. It's the water from the reject line going through the air gap in the air gap faucet. Or some people might just want to replace it with a fancier faucet. They want something that's more aesthetically pleasing. That's fine. You can do that, but just make sure that if you're replacing that faucet, you're replacing it with the lead-free faucet because the water is going to be corrosive. And also make sure that then the drain line has a proper air gap installation. So this picture was taken from our building. That black plastic line is the reject line from the RO system in our break room. It was installed by a WQA certified water treatment professional. You can see they did the proper air gap there. There's a gap above that standing drain pipe. So if anything backed up in the sewage, it wouldn't be able to go up and contaminate our RO system. Unfortunately, the other copper lines there lead to water fountains, and those were installed by licensed union plumbers. So just the point is here, this is a common mistake that is made. Air gaps are often messed up. Even plumbers will do it wrong. So it's something to watch for in the field. You don't want the ability of a septic system that's backing up to contaminate your water treatment system. One of the other things to keep in mind, a lot of these systems will require some sort of flow restrictor on the drain line. The way you might notice that somebody messed this up is that even when the system is brand new, the system struggles to fill the tank. It's not able to fill that tank in a rapid manner. And that's because they probably forgot to put in the flow restrictor on the drain line. If you look in the manual, you'll be able to find the instructions on how to install it, and there'll be part in there where you can buy it to replace it. Or a lot of times we'll see this is just laying there right by this system. They didn't install it, didn't know what it was for, they just left it there, or they left it in the box. One of the myths we run into a lot is RO water is too pure, it will harm your body. The bottom line here is you need water, your body needs water for hydration. You get your nutrients from a properly balanced diet. If you're actually eating a properly balanced diet, the amount of nutrients that you could possibly get from your water is going to be trivial. But we do often see this used as we often see this used as a misleading sales tactic, unfortunately, for people who are trying to sell you something that isn't an RO. And I'm not here to tell you RO is the best technology out there. I'm just saying we feel this is a misleading statement, and it is sometimes being used as a sales tactic. We do have a white paper on this where if you'd like to get more into the science and the published science on this, you're welcome to get that from me. Just reach out to me afterwards and I'll send it to you. Examples of bad field modifications I've seen, again, don't plug the drain line. People don't like the sound of the gurgling because if the drain line's properly installed, there'll be an air gap under the sink. Even without the air gap faucet, you will hear that gurgling under the sink. And so people just say, I didn't like the sound of that, I just plugged it. The problem with plugging it, even if, first of all, you're probably going to destroy your membrane. But even if you have the right water chemistry where you're getting away with it without destroying your membrane somehow, you have now compromised the performance of your system. Because remember, the salt passage across the membrane is based on the concentration gradient. You're now not rejecting anything because you plug the drain line. So you're just building up the concentration gradient across the membrane. You're just pushing more contaminants across the membrane. Another modification we've seen is the permeate pump is moved from downstream of the membrane, between the membrane and the tank, to downstream of the tank. Why would you do that? Because it makes it fill your cup faster. It's another sort of trick people do to make it fill your cup faster. The problem with it, the way you'll notice this is they've done this, is the permeate pump runs off hydraulic pressure from the reject line. So it's using pulses of pressure to push water into the tank. That's how it normally works. When they put it downstream of the tank, it uses those same pulses of pressure to squirt water into your cup. It's like somebody is milking a cow into your cup. It's like you'll get squirts of water into your cup, and then you know, okay, yeah, they've modified this and removed the permeate pump from where it's supposed to be. And again, the problem with that is now you've compromised the performance of your system. You've compromised the pressure gradient across the membrane, so you're not going to get the water quality you should expect. If you do run into things like this and you need to bring in a water treatment professional, you can go to our website. There's search engines there where you can find a water treatment professional in your area who's agreed to abide by our code of ethics, or better yet, you can find a certified water treatment professional in your area who's agreed to abide by our code of ethics. This is my contact information. We can provide free technical support to government agencies, NGOs on point of entry systems. We don't sell anything. You can't buy any systems through us. I can't recommend a specific brand or model to you, but I can definitely help you with technical information like this, use limitations. I can help you navigate product certifications and understand that kind of stuff. And do we have time for questions? 8 minutes, okay. So I'll leave this slide up for a second since this one's not in your binder. If anybody missed any of the answers to those questions, here they are. Okay. Do you have any particular RO reject water disposal recommendations for well owners, assuming not connected to a sewer? So the types of systems I'm talking about here, you would have the amount of contaminant that's going to go out into your sewer line is actually going to be slightly less. The mass amount will be slightly less than what you have coming in. So with or without the RO system, if you remove the RO system, you'll actually have slightly higher mass going out. You will actually have a very slight concentration factor, though. It would be something on the order of, say, 10% of, let's say you're using this system to treat 0.5% of the water, the indoor water usage in the home that's actually going out into the septic system, then it would be 10% of 0.5%. It would be something probably you wouldn't be able to measure in terms of the concentration increase. Bottom line is the RO system, again, is not adding anything. It's not like a water softener where you actually you're adding salt and there's some salt that's being discharged. It's just diverting things from your cup. So whatever you have coming in is what you're going to have going out. Do you suggest for folks, and I also should say we are actually working on a calculator that will help people understand that concentration factor for commercial applications, because if you are dealing with a larger commercial RO system, then you can have a measurable amount, at least, probably still trivial, but at least it could be an amount that could be measured. So if you're interested in that, reach out to me, and as soon as we get the calculator done, I'll send it to you. What do you suggest for folks in rural areas with few trained water treatment specialists? I mean, we do provide help to consumers. We have a lot of consumer resources. We have a free water treatment for dummies booklet. But in terms of if you're a do-it-yourselfer, you are installing these systems on your own, I would just stress that they need to follow the instructions. Everything they need to know, if the system is certified, everything they need to know is in the manual. Problem is people don't read the manual, and they don't read the instructions. But it's all in there. But that's one of the certification requirements. Can you please talk about point of use versus point of entry RO systems? Yes, point of use systems, what we differentiate between point of use and point of entry is really, are you treating the water at the point of use, like underneath your sink, where it's going to go to a faucet? Or are you treating the water as it comes into the home, which would be like point of entry, like a water softener would typically be installed where the water comes into your home, you're treating most or all of the water used in your home. And there are whole house RO systems. They're not as popular as these smaller systems because, again, the water is going to be corrosive. So you need to make sure that either you remineralize the water downstream of the RO system and then readjust the pH, or you have plumbing in your home, which is all plastic or non-metallic plumbing. What is the other, I guess the other disadvantage too that some people, the reason the whole house ones are not as popular as the other ones is with the whole house system, you're going to be treating all the water used in the home, right? With the small point of view system, you're treating less than 1% of your indoor water usage, not even counting your outdoor water usage. So it's a pretty trivial amount. The amount of water that goes down the reject line in terms of total volume is pretty trivial because you're not using it to treat that much water. If you are treating the whole use, all the water that you use in your home, then the amount of water that's going to go down the reject line can add up. It can be significant. So you just want to make sure that you calculate what that's going to be and you're comfortable with that. What is the proper disposal of the filter membrane that's captured contaminants? There is no capture of the contaminants. You have the pre-filter there, which captures sediment and chlorine. The filters, all of the filters are exempted from RCRA in terms of disposal. So any household waste can go directly into the landfill. But there is no actual capture in the membrane of things like PFAS. You're not capturing it. It's just diverting it from your cup. Is it feasible to plumb RO to serve kitchen tap and fridge faucet? I mean, not the kitchen tap in terms of the tap that you're going to want to use for washing dishes and stuff like that. The system would probably not keep up with that much water demand. They're only made to generate enough water to use for drinking and cooking. But people definitely do use them for the refrigerator. So for your refrigerator dispenser, I've seen RO systems plumbed into that very commonly. Okay. All right. Thank you.